So today we're going to look at lesson 2-8. You might want to pause the video for each problem that I do and write down the original problem and then restart the video. There's 4 problems that we're going to go through today. We're going to graph inequalities that have 2 variables. So for the first one we're going to look at, this is a linear function. It's in the form y equals mx plus b. So it's really just the graph of a line. But remember, when you have an inequality sign, we have to decide, do we have a solid or a dotted line? And then are we going to shade above the line or below the line? So for the following, let's write down, these are just in general items for any inequality graph. So if you are trying to decide if you have a solid or a dotted line. So a solid or a dotted line, you're going to be looking for the following. If it's a solid line, it'll be greater than or equal to, your inequality will be, or it'll be a less than or equal to inequality. If your line is dotted, it will just be a greater than or a less than sign. So the difference is, if you have an equals to, you're going to fill in the whole line. It's just like a closed circle. If you don't have an equals to, it's going to be a dotted line, and you're not going to fill in that line. So it's like an open circle. All right, then the other thing that you're going to look for is shading. Are you going to shade above the line or below? If you shade above the line, that would be greater than or equal to. If you shade below the line, that would be less than or equal to. So those are really the 2 different things that you have to watch out for. Other than that, we're just going to graph this as if it were y equals negative 2x plus 1. Then we'll look at the inequality sign when we're done and decide whether it's dotted or solid, and then whether we shade above or below. So the first thing we're going to look at is the fact that this is our y-intercept. So if that's our y-intercept, then I'm going to plot a point on the y-axis at positive 1. And then my slope is negative 2. So that means, and so maybe I will write down here that b is equal to 1. So that was our first step. And then our slope is equal to negative 2, but I'm going to write it as negative 2 over 1 or 2 over negative 1. So that means I'm going to go down 2 to the right 1 or up 2 to the left 1. It's always a change in y over the change in x. So I'm going to plot, I'm going to go up 2 and to the left 1. So I'm going to plot that point. And I'm going to continue up 2 to the left 1, up 2 to the left 1 until I run out of room. And then we're going to go in the opposite direction. Now I'm going to go down 2, but to the right 1. And then down 2 to the right 1, down 2 to the right, and down 2 to the right. Now the only thing I need to decide is, am I going to have a solid or a dotted line? And because my inequality sign has an equals to, I am going to have a solid line. So I am going to take, trying to find my line function. Okay, so I am going to take and connect those points with a solid line all the way through. All right, put an arrow on both ends because that line goes infinitely in both directions. Then all you have to do is decide whether you're going to shade above or below. Since it's a greater 2 sign, we are going to shade above the line. Now some of you know immediately where above this line is. You know whether it's here or whether it's here. Others of you have no idea. You're like, I have no idea. So my suggestion would be to start up here at the north part of your graph and pretend like you're in a helicopter and you're going, or an airplane, and you're going to drop a person on the y-axis until they slide and hit your line. Wouldn't they land on the line on this side? And so they might look like this. I have incredible drawing skills. So there you would be. You would definitely land on this side of the line. You wouldn't land on this side of the line because you would end up going through, assume that this is a mountain. You would end up going through the mountain and you'd be underground. You'd be dead. And we're going to assume for our purposes here, you're not going to die parachuting out of that plane. You're going to land on the ground, and this would be the side that you would land on for this particular line. So for this line, if you're going to shade above, above means that you are going to be in the shading. Below means that you are not going to be in the shading. So since we want to be above, we're going to shade in the direction where you are and put you in that shading. So let's shade over here. Okay, so any ordered pair that you come up with in here would be a solution to this inequality. So there is an infinite number of ordered pairs over here in the shading. In addition, you could choose any ordered pair on this line here to be a solution. So I'm going to select 2 of them. And let's see, I think I'll select this ordered pair right here. And that ordered pair is +3, +2. So I'm going to put my y value is going to be +2. So on the left, I have +2 and then greater than or equal to. And then I'm going to take my 3, which is my x, and substitute it into this side. So 3 times -2 is -6, plus 1 is -5. So I want to look at this inequality that we just created. Isn't 2 greater than or equal to -5? That's a true statement. So that's a true statement. So that means that this is one of the solutions to this inequality. And I could do this all day long, choose any ordered pair within that shading. What if I chose an ordered pair that was physically on the line, like maybe this point right here? That point right there is -1, +3. So my y value is going to be +3. So I'm going to put +3 for my y value and then greater than or equal to. And I'm going to take my x value of -1 and substitute it in here. So -1 times -2 is +2, plus 1 is 3. Isn't 3 greater than or equal to 3? So that's also a true statement. That also is a true statement. So this is considered a solution to that inequality. Well, what if we chose an ordered pair that is outside of the shading and not on the line, like this one right here? This one would be -1, -3. So my y value would be -3, greater than or equal to, and I'm going to substitute in a -1. So -1 times -2 is +2, plus 1 is 3. And clearly, -3 is not greater than 3. So this would be a false statement, and it would not be a solution to our inequality. All right, so let's move on to example 2. So for example 2, you are going to graph a different function. So the first thing that you need to identify when you're graphing a function is what is the parent function. So this says y minus 4 is greater than or equal to 2 times the absolute value of x minus 1. So pause so you can write all this down and then restart the video. So the first thing you need to make sure is that you have, no matter what inequality you're given, you need to make sure that y is by itself. So the first thing I'm going to do is get y by itself, and I'm going to add 4 to both sides. And now, knowing that the parent function here is absolute value, I know that my parent function is, whoopsies, I know my parent function is y equals the absolute value of x. So knowing that, when I add this 4, I'm going to add it over here because that 4 is going to end up being my k. And I want my k to the right of the absolute value signs. So my 4s are going to cancel, so I have y greater than or equal to 2 times the absolute value of x minus 1 and absolute value, and then plus 4. Okay, so let's think about this. I'm going to plot my parent function. So my parent function is the y equals absolute value of x, and that's this function right here. So remember, I'm trying to get you to start just knowing how to plot these without a table of values. Now, you certainly could use a table of values, but I'm trying to get you to graph these without using a table of values. So the first thing I want to do, I've got several transformations occurring. This causes a vertical stretch of 2, and then this is inside the function, so it's affecting x, and x goes in a right-left direction. So it's either right or left, and it's the opposite of what you think it should be. So since it's a minus 1, we should be thinking in a positive 1 direction, so we're going to go to the right one. This is outside the function, so it's affecting y, and y it goes up or down, and we want to go in the same direction as we think it would be. So since it's a plus 4, we're going to go up 4. So let's label those transformations. So we have a vertical stretch of 2, and I'm going to color code my stuff. And then I also have a movement of right 1 and then up 4. Okay? So you will 100% of the time do a reflection first. So if you have a reflection, you would know you would have a reflection because A here would be negative. So we don't have that, so I'm not going to do the reflection. The next thing you would try to do is your vertical stretch or compression. So because I have a vertical stretch of 2, we're going to do that next. And if you recall, the shortcut to a vertical stretch of 2 would be to take the slope, take this vertex right here, and this is very similar to a slope. So the slope of this line right now is 1, but we want to stretch it to a slope of 2. So we would go up 2 to the right 1, and we're only going to do it to the vertex. So we're only going to do it to the vertex. So I'm going to go up 2 and to the right 1, which puts me here. The vertex is going to stay the same, so that stays the same. And then I'm going to continue, but from this point. I'm not going to do it to every single point. I'm going to start here at the vertex. I went up 2 to the right 1. That's my slope of 2. And then continue in that pattern. Up 2 to the right 1, up 2 to the right 1. So this becomes my stretch. And you can see that this arm right here, the parent function, has stretched and it's now closer to the y-axis, which is what a vertical stretch does. Now we also need to do it to this side, so we're going to go up 2 but to the left 1 to create that other branch and that other stretch. All right, so there's my vertical stretch. Then I'm going to take each of these blue points here and I'm going to move them right 1 and up 4. Well, some of those blue points I can't move up 4. So we'll do our best. So this one I can't move up 4. But this one I can move right 1 and then up 1, 2, 3, and I'll be a little off the board, and that's okay. So I'm going to go right about here. And then the next one, I'm going to go right 1 up 4, so I'll land here. And then the next one, I'm going to go right 1 and up 4. And then this one, I'm going to go right 1 and up 4, so I'm going to land there. This one goes right 1 and up 4, so there you see the bounce occurring. So I'm going to land right here. And then this one is right 1 and up 4, and that's going to be the last one that I can put in there because I'm going to run out of room. Okay, so then the next thing I have to remember to look at is, I have to look at my inequality. Do I have a solid or a dashed line when it's equals to? So because it's equals to, I'm going to have a solid line. So then that's the next thing. I'm going to connect with a solid line. I'm gonna connect all the way. Maybe. There we go. Sorry, it's a little rough. All right. So my pointer does not want to connect full where I want to put it, so sorry. Put my arrow down there because my program won't let me go further. So it's a little crazy. Okay, then now that I have my solid line, then I need to decide, am I shading up above or down below? Because it's greater to, we want to shade above the graph, which is going to be up here. Around here would be below the graph. So it tends to be easier to shade the absolute value graphs because, I don't know, it's easier to see what's up above because it's that V shape versus below. All right, so then I want you to select a solution. So find a solution and write it down. So one of my, I'm just going to select any one at random. I'm going to select this one. So that solution is 1, 2, 4, 6, 8. So that solution is 1, 8. That's just one of an infinite number of solutions you could have chosen. All right, let's look at example 3. So for example 3, I have actually drawn a graph for you, and I want you to write the equation of the graph. So pause the video so that you can draw this graph and the directions, and then I want you to try to write the equation of the graph that you see. Then restart the video and listen to my explanation and adjust your errors if you got something wrong. Okay, so hopefully you have drawn your graph, and so the first thing that you want to identify is what is the parent function that you see here. Because it's a V, it is upside down, but it's a V, your parent function has to be in the form of y, and it's not going to be equals because it's clearly an inequality with the shading, the absolute value of x, right? So we're going to have an inequality sign here. We might have a vertical stretch or compression, or we might have a reflection. We might have a movement right or left, and we might have a movement up or down. So let's figure out our inequality. Since we have a dotted line, we know that we don't have an equals to. And since the shading is all above here, we know that it's greater than. So we have just a greater than sign. Then we're going to look at our reflection and or a vertical stretch or shrink. So because this V has been flipped upside down, we know we have a reflection. So I know there's going to be a negative out in front here. You want to look for a stretch or a shrink. So look at the slope of the line. If you go from the vertex, we go down 1 to the right 1, down 1 to the right 1. The slope of that line is -1, which we want to look at the absolute value of that slope. So that's really a slope of 1. So this does not have a vertical stretch or a compression. If you saw a vertical stretch or compression, it might look like this. Maybe you'd have this vertex here and you would go down 1 to the right 3. So maybe the next point is over here. And if you went down 1 to the right 3, that would be a vertical compression of 1/3. Or maybe your next point was right here on the x-axis here at -1. Well, that means that you would have gone down 2 to the right 1, which gives you an absolute value slope of 2. So then you would have put a 2 here. So since we only have a reflection, we're just going to put a negative out in front. Then the last thing that we need to look at is movement. So this would have been the original vertex. So we must have moved left 2 and up 2 to get to this new vertex. Left 2, up 2. So left 2 is going to be in here. Left 2 would normally be a -2, but because it's inside the function, we're going to do the opposite of what we think we would do. So left 2 is going to become a +2. Then the up 2 is in the y direction, so it goes outside the function. And for the y direction, we do exactly what we think we should. So since it's a +2, it's going to remain a +2. And so this becomes the equation or the inequality to that graph. So if you did that 100% correctly, good job. Let's do our last problem. So for our last problem, I want you to graph this on your own. So pause the video, see if you can do all the steps necessary to get this graph where it needs to be. If you struggle on your first step, you can start the video and then pause it once you get that first step done, and then see if you can do the next step. Try to do as little of listening to me as possible until the very end. Okay, so hopefully you paused the video. So the first thing that you should have done was to get y by itself. So you should have subtracted 2, and then you're going to put that 2 over here on the right side. And so you end up with y is less than negative 1/3, absolute value x plus 3, and absolute value, and then minus 2. So this is the inequality that we're going to graph. You have to identify the parent function. So the absolute value of x, remember, is that v shape. So we know that we're looking for a v shape. So I'm going to actually graph the parent function here. So the parent function of y equals the absolute value of x would look like this. Remember, I'm trying to get you to graph these without using a table of values. If you use a table of values, that's fine. Okay, so that's my parent function. Then the first thing I want to do is reflect. So here I have a negative, so I'm going to reflect, and so I'm going to color code this. So let's see, maybe I'll reflect in pink. So my first translation is to reflect over the x-axis. So remember, to reflect, you want to go the same distance from the x-axis in the opposite direction. So since this one is 5 units away, I'm going to go 5 units away on the other side. And then the next one is 4, and then 3, and then 2, 1. The vertex is on the line of reflection, so it stays the same. And then here we go. So that's my reflection. Then the next thing I'm going to do is a vertical stretch or shrink. And you have to go in this order if you're going to graph it this way. Now, some of you might do the reflection and the stretch or shrink at the same time. That's fine. So I'm going to apply this slope to the vertex only. And I'm going to do this in blue. So I have a vertical compression of 1/3. So 1/3 means I'm going to go down 1, because I know I want to be down here on this side because I reflected it. So I'm going to go down 1 and to the right 3 and plot a point. And then I'm going to do that again. And then that's all the room I have for that one. Then I'm going to do it to the other side. Down 1, but to the left 3. Down 1 to the left 3. So as you can see, this is going to be my reflection along with my vertical compression. Then the last thing I have to do is our movement up, down, right, left. So plus 3 is going to be a left 3, and minus 2 is going to be a down 2. So I'm going to do that. I'll do green. So we're going to go left 3, and we'll go down 2. So this one I'll be off just a little bit, but I can go left 3 and be over here, and then down 2 I'll be right about here. I'm trying to get my pen commands out of the way. So left 3 and then down 2, I don't know, would be right about there. And then the next point, left 3, down 2. And then my vertex, left 3, down 2. And then this point, left 3, down 2. And so you can see that bounce occurring. And then this final point, left 3, down 2. Whoops, that was a crazy point. All right, then I'm going to connect those with a straight line. Oh, wait. We have to decide whether our line is going to be shaded or dotted. So because I have a less than sign, we are going to have a dotted line. And then because I have a less than sign, we're going to shade below. All right, so here we go. Let me do my dotted line. It's going to take me a little bit. All right, then put an arrow. And now my shading is below. So then, I don't want to shade that color. We'll shade here. All right, and that's all there is to it. The last thing I want to point out is if you were asked to find a solution to this inequality, you could choose any solution that's in the shaded region, but you would not be able to choose a solution on this line because it's a dotted line. So it's a fence, but since it's not filled in, you can't choose it as a solution. So this might be a possible solution here, which would be the ordered pair -1, and then 2, 4, 6, 7, so -7. That's just one example of a solution. All right, good luck. Let me know if you have any questions.